Hello everybody, welcome into another lesson. So today we are going to talk about power reducing formulas for trig functions. Now this is a very important lesson because these are used all the time in calculus, especially with integration. If you have the sine squared of x or the cosine squared of x, even if you're taking calculus now and you're trying to integrate some of these, it's awfully hard to try to integrate these directly. You need a power reducing formula to be able to do that. Now, of course, if you're doing integration, you have the other four functions squared, such as tangent squared, secant squared, tangent squared and cotangent squared. You can use Pythagorean identities. And then secant squared and cosecant squared you have more direct integration results for. But if you're going to do sine squared or cosine squared, you need power reducing formulas. So we know that the sine squared of x equals the sine of x times the sine of x. And power reducing formulas are largely, they're based off the product of sum formulas, which will be the topic of the next lesson. So that would work as 1/2 of the quantity of the cosine of x minus x. You take each quantity of the sine, each of the angles you're trying to take the sine of, so it would be half of the cosine of x minus the cosine of x plus x, which really would equal half of the cosine of 0 minus the cosine of 2x. Well, what's the cosine of 0? That's just 1. So the formula, the power reducing formula for the sine squared of x is half of the quantity of 1 minus the cosine of 2x. And the cosine squared of x works relatively similar. The only difference is it's plus instead of minus. So in the end you end up with 1/2 of the quantity of 1 plus the cosine of 2x. And these, if you're doing integration in calculus, would enable you to successfully do integration as opposed to trying to use this, which just wouldn't work to integrate. So we're going to do some examples here of using these power reducing formulas. I do have to erase these because we will run out of room, but let's say you have something like cosine to the 4th of x. The idea is for today's lesson, we're going to take all of these and we're going to put them into a single first degree quantity of the cosine function. So how are we going to get there? Well, first, let's understand that the cosine to the 4th of x is the same as the cosine squared of x times the cosine squared of x. Well, okay, or you could actually, probably an easier way to write this would be to say the cosine squared of x to the 2nd power. That's probably an easier way to write it. Now, we're going to take the power reducing formula for the cosine squared of x, but we have to square the entire quantity. So it's going to be, of course, cosine squared of x is 1/2 times 1 plus the cosine of 2x. So we're going to square this whole quantity because this is what the cosine squared of x is equal to. So this would turn into 1/4 times 1 plus 2 times the cosine of 2x plus the cosine squared of 2x. Well, we still have a cosine squared. We need to get this into a cosine to the first term. No big deal, we can do that, but first, why don't we distribute this 1/4? So far we're at 1/4 plus half of the cosine of 2x, now plus 1/4 of the cosine squared of 2x. And it's going to end up being this portion right here that we have to use the power reducing formula yet again. So let's go ahead and do that here. So this would turn into 1/4 plus 1/2 of the cosine of 2x plus 1/4 times the quantity of 1/2 times the quantity of 1 plus this time the cosine of 4x, because if you add 2x and 2x you're going to end up getting 4x. And we can simplify this now into 1/4 plus 1/2 of the cosine of 2x plus 1/8 plus 1/8 of the cosine of 4x. The only other thing we can do to simplify now is add the 1/4 and the 1/8. You'll end up getting 3/8. So your final answer should end up being 3/8 plus half of the cosine of 2x plus 1/8 of the cosine of 4x. And that would be the final solution. If you wanted to get this in terms of cosine to the first power, you would get 3/8 plus 1/2 cosine of 2x plus 1/8 cosine of 4x. And that would enable you to integrate this in calculus as opposed to trying to deal with cosine to the fourth power of x. And when we get into integration in calculus, this will make a lot more sense. Those types of problems from where I'm going to teach them will actually largely be in Calc 2 as opposed to Calc 1. We'll do some integration in Calc 1, but they won't be that grueling. Calc 2, on the other hand, well, we'll get to that when the time comes. But now let's say we're going to deal this time with sine to the fourth power of x. So let's deal with sine 4 of x. Okay, well, that's the same thing as sine squared of x, that quantity squared. So we need to use the power reducing formula for the sine squared of x. So keep in mind we got to square this whole quantity. This would end up being 1/2 times, this would be 1 minus the cosine of 2x. All that, the whole quantity is going to be raised to the second power because it's sine squared of x squared. Okay. Well, let's square this. So you would end up getting 1/4. We don't even need to keep the brackets now. This would end up being 1/4 times the quantity of 1 minus 2 cosine of 2x plus the cosine squared of 2x. And I think before we go any further, let's go ahead and distribute the 1/4. So this would turn into 1/4 minus 1/2 the cosine of 2x plus 1/4 the cosine squared of 2x. Well, we still want to get this into terms of cosine to the first power. So this portion here, a fourth of the cosine squared of 2x, we have to apply the power reducing formula yet again. So let's go ahead and do that. This would end up being 1/4 minus a half of the cosine of 2x plus 1/4, now here's where it gets fun, times the quantity of 1/2, because the cosine squared of x turns into 1/2 times 1 plus the cosine. This time would be 4x, because 2x plus 2x is 4x. And now let's distribute that 1/4, so you'll have 1/4 minus 1/2 of the cosine of 2x plus 1/8 plus 1/8 of the cosine of 4x. And all we can do now to simplify is add the 1/4 and 1/8. You'll end up getting 3/8 minus 1/2 of the cosine of 2x plus 1/8 the cosine of 4x. And that would be your final solution on how you would simplify this into a cosine to the first power function. So this would be 3/8 minus a half cosine of 2x plus 1/8 times the cosine of 4x. Alright, let's see. Now what if we had sine squared of x, cosine squared of x? So they're double teaming on us this time. We have the sine squared of x minus the cosine squared of x. So with each of these we got to apply the power reducing formula. So the sine squared of x, that's 1/2 times the quantity of 1 minus the cosine of 2x. And then the cosine squared of 2x, that's going to end up being 1/2 times the quantity of 1 plus the cosine of 2x. So before we go to FOIL, why don't we distribute the 1/2 in each of these to make life a little bit easier? So this would end up being 1/2 minus a half of the cosine of 2x. That quantity times 1/2 plus a half of the cosine of 2x. Now, as you can see, this is definitely factored as a difference of two squares. So when we go to FOIL, that's what we'll get. We'll end up getting 1/4 minus a fourth of the cosine squared of 2x. But we have another cosine squared. We want to get this in terms of a cosine to the first function. So yes, we need to take that cosine squared and do a power reducing formula on that yet again. So we'll take 1/4 minus 1/4 times the quantity of 1/2 of 1 plus the cosine of 4x. which now we need to distribute that negative 1/4, so you would end up with 1/4 minus 1/8. Well, wait, let's wait to distribute that 1/4. We have 1/4 minus 1/4 of the cosine squared of 2x. Now we distribute that negative 1/4. So this would be minus 1/8 minus 1/8 of the cosine of 4x. And for the final step to simplify this, we subtract 1/8 from 1/4. That would end up giving you 1/8 minus 1/4 Why did I do the cosine squared of 2x there? Hold on. I rewrote the cosine squared of 2x. Ugh. I made it way harder than I needed to. Hold on a second. Just forgive me for that. So this would end up being 1/4 minus 1/8 minus 1/8 of the cosine of 4x, which when we simplify would end up giving us 1/8 minus 1/8 of the cosine of 4x. There we go. That makes more sense. So the sine squared of x times the cosine squared of x, if you want to write this as a function of the cosine of a cosine to the first power, would be 1/8 minus 1/8 of cosine of 4x. All right. Let's see. Let's do the sine squared of 2x. We'll take it a little bit easier this time. Let's do the sine squared of 2x. So let's use the power reducing formula again. So this would be 1/2 of the quantity of, alright, so it starts out cosine of 2x minus 2x, which would turn into the cosine of 0, which is just 1. Then this would be minus the cosine of 2x plus 2x, which is 4x. So honestly, you could write that sine squared of 2x as 1/2 of the quantity of 1 minus the cosine of 4x. You could totally do that. Now, what if I had something like this? The cosine squared of x over 2. So it looks like we're going to use a half angle formula, only we really don't need to. We actually really don't need to use a half angle formula. This is just a simple power reducing formula. So if I take 1/2 of the quantity of the cosine of x over 2 minus x over 2 plus the cosine of x over 2 plus x over 2, what is that going to give me? Well, that would end up giving me 1/2 of the quantity of the cosine of 0 plus the cosine of x, which would give me 1/2 of the quantity of 1 plus the cosine of x. So that cosine squared of x over 2 simplified nicely into half of the quantity of 1 plus the cosine of x. So a half angle formula was not necessary this time. I got one more for these. And this one's going to be a good one. Let's say we do sine squared of x over 2 times the cosine squared of x over 2. So it looks like we have two half angles. And in theory, we have half angles. That much is true, but we're not going to need to use a half angle formula. We can just use the power reducing formula. So let's deal with the sine squared of x over 2. This is going to be equal to 1/2 times the quantity of, let's see, so the cosine of x over 2 minus x over 2, that's just the cosine of 0. Then minus the cosine of x over 2 plus x over 2, that's just the cosine of x. Okay, then we take that times, let's do the cosine squared of x over 2 power reducing identity. So this would end up being 1/2 of the quantity of, alright, so cosine of x over 2 minus x over 2, that's the cosine of 0 again. But this time plus the cosine of x over 2 plus x over 2, that's just the cosine of x. So already you can see we did not need a half angle formula. This would simplify into the quantity of 1/2 times 1 minus the cosine of x times the quantity of 1/2 times 1 plus the cosine of x. Well, before we FOIL or do anything like that, let's distribute the 1/2 in each of these. This would turn into 1/2 minus 1/2 of the cosine of x times the quantity of 1/2 plus 1/2 of the cosine of x. Which when you FOIL, you'll end up getting 1/4 minus 1/4 times the cosine squared of x. Well, we're almost there, but we still have this cosine squared of x business. So we have to apply the power reducing formula yet again. So let's go ahead and apply the power reducing formula to the cosine squared of x. So this would turn into 1/4 minus 1/4 times the quantity of 1/2. Now cosine squared of x, that's going to be 1 plus the cosine of 2x. Which would simplify this into 1/4 minus 1/8 minus 1/8 of the cosine of 2x, which the only thing left to do to simplify this is subtract that 1/8 from 1/4. You should end up getting 1/8 minus 1/8 of the cosine of 2x. So that sine squared of x over 2 times the cosine squared of x over 2 equals 1/8 minus 1/8 of the cosine of 2x. So that's it for power reducing formulas. Next lesson's also going to be important because those are also used in calculus. We're going to talk about product to sum formulas, which these were based off of. So I hope everyone has a great day. Take care.